So hi, I want to show you something all about batteries. So these batteries were taken out from a Ninebot Mini Pro. This is a scooter, it's like a Segway, something like this. The battery was broken and now I will show you why. So I took the cells out of the battery, and if we test them, we will see what is the condition of these batteries. So you can see 0.6, 0.75, 2.8, and then 0.9, 0.85, 0.88 and 0.84. Now I've said before that if the batteries get below 2.5 volt, then you can throw the batteries away, but I was seeing so many batteries over the years, and I have to say that what you think for one battery is not obvious for other battery, and eventually you can't really know if this battery can be revived or not. Now I will show you. This was taken from this battery. This is not the original battery. I think this is like a copy, but they are all the same. This is 15 cells. Each cell is 2 batteries in parallel, so total we have 30 cells in this design, and the BMS stopped the battery from working, and when the voltage is so low, so I decided that I don't want to play with it, and I decided to disassemble all the cells, and if I will be able to revive them, maybe I will use them for something else. So in the meantime, I will try to see if these cells can be revived. I will use this ISDT charger. This charger supports 2S till 8S. What I like about it is that it has built-in DC to DC converter, which means you can apply to it 12 volt, and if you have 8 cells, and maximum charge is 4.2, so the maximum voltage is above 32 volts. It's not a problem for it. It will do the upscale for the voltage, and it will boost the power in to the desired voltage. So I will try to use it. I'm using this because I want to charge all the cells together, and I don't want to charge each individual cell alone, because this will take, of course, a lot of time. So the time consuming is important in this case. I will try to connect everything. I will try to revive these cells, and then in order to check if they are okay, we will need to be at discharge. Now, one thing about batteries that got to fully discharge, of course they will not behave like a new cells, but maybe we will be able to use them, which means that probably the cells, even if they will hold charge, they will have other problems, such as getting more heat when they are at full load. That can be 10 to 20 amp continuous, and this will cause the cells to heat more than new cells, and the reason is that the internal resistance go up, and if the batteries get to this case, so obviously they are not like new, so they will be not like new, but it doesn't say that you can't use them to other project, maybe not to scooter, but to other consuming for 5 amp or 10 amps. We will test it. So first step is to connect everything and try to charge. So I will try to charge this 4 cells, because 2 and 2, each 2 in parallel, so 4 cells. I have already prepared the balancing cable for it, and I will connect everything and charge and see what we get. So here is my setup, everything is connected, the balancing cable, the output with magnet to the cells, and now I will apply 12 volt 1 amp to the charger, the smart charger, and now we don't see any voltage, but we can see the total is 3.8. and now let's configure it and see what we can do. So I will move it to 4S, and then we'll do task of charge. This is already set, and current 1 amp, and start. Perform unbalancing, yes. So I had to pre-charge the cells to 3.2 volt, and now it started correctly, I guess. So it can't revive the battery if they are totally low voltage, below some minimum probably. So right now we can see that it is working correctly. We can see the input voltage, it is charging at 1 amp. I've just started, so we can see the capacity 12 milliamp hour. Okay, what other thing we can see? We can see each cell internal resistance and each cell voltage. It is balancing through the charging rate. So I will do a full charge, and then I will wait for some time, and then I will do the discharge in order to see that it's really hold the capacity, and afterwards we can get to conclusion if these cells can be revived or not. So let's wait for the final results. So we can see that it is continue to charge. I want to show you a few things. First, a good sign that the batteries are still okay, that they are not getting hot. I'm charging at 2.6 amp, which means each cell is 1.3 amp because 2 in parallel, and I can go to the internal resistance and I can see that the numbers are about 19 ohms, and one cells is 17 milliohms, sorry, and 17 milliohm or 20 milliohms is basically a good number, and we can do a very quick calculation. The power, if we consume 10 amp continuously, so the power, the heat power on the battery is I square R. In our case is 10 multiplied by 10 is 100, multiply in 20 milliohms, so we have 2 watt heat on each 2 cells. That means each cell is 1 watt heat, which is acceptable. That means that we can even go to higher current of discharge and it looks good. So we will wait for all the cycle to complete, and then we will do the discharge test to see the real capacity that is held in the battery. And I don't know what is the maximum discharge that I can do here, but we will do a discharge with the maximum current. Maybe we'll use another tool, and then we'll get to conclusion about if we could really revive these batteries or not. Okay, so now we are close to 4 volt to maximum voltage. The stopping point is near 4.2 volts, and it is interesting to see one thing that I will show you now, and this is that if I'm switching to internal resistance, we can see that the resistance is lower than we've seen before. all the cells are pretty cold, not very cold, but let's say less than 30 degrees for sure, maybe 27, 28 degrees, something like this. So all in all, everything is okay for now. We will wait to the maximum limit and then we do a full discharge capacity test. Okay, so now we are very close to 4.2 volt. I will soon stop it and we'll continue the discharge test. But first I found some datasheet. The datasheet shows that each cell can supply 10 amp continuously, and the capacity is 2850 milliamps. We have two cells, so it's around 5.7 amp hour, and the peak discharge for each cell is 17.5 amp, which means in our case 35 amp peak can be okay for 4 seconds. Other than this, the maximum voltage is 4.2, the minimum is 2.5, and now we will do a discharge. I will stop the charging, and okay, and we'll go to the discharge task. So I will go to the discharge and I will try to see what is the maximum current that I can do it. 1.5 amp, okay, and now we will start and we will have the real capacity and see if we could revive the cells. So begin the discharge and we will see the real capacity later. So eventually I decided to go to this load because the charging was only a 900 milliamp and this is too low. So I will move now to the power charger and I will discharge the cells, let's say in 4 amps. So we have now 4 amps of discharge, and now we will measure the capacity and see what we got. So I have moved it now to 5 amps and already 250 milliamp hour. Let's see temperature. So we can see the cells are pretty cold. All the cells are below 30 degrees Celsius, and we can see each cell voltage here. So we have 3.81 till 3.84. They are pretty balanced, and maybe I will try now to move for a moment to 7 amps. By the way, the wires are not very suitable for high current, the wires that I put here, but for a short period it's okay, probably. You can see that the current go high immediately, the capacity I mean. The cells are still very cold. Nothing dramatically happens because these cells are, for such a current, it's not a big deal for them. So we are, again, the cells are good to 60 degrees Celsius. we are not even half. That means that the cells can handle this current easily without any issue. But since I want to see the capacity, I will drop now the current to again to 4 amp. And we'll continue. So surprisingly, we can see that we are already almost 4 amp hour, and this is more than I've really expected. So we can see that the cells could revive easily without any issue, although the voltage was around 0.6, 0.8 volt at the beginning, and it holds charge and the cells are okay. Probably there are the capacity is near the real capacity that is written on the battery, which is 5.2 amp hour. We are already close to 4, and there is a lot of voltage you can drop till 2.5 volt. Let's look at the temperature. So 32, we can get to 60. You can see that here the temperature is very low. Maybe I will zoom. Okay, so here we have 32 degrees on the 2 cells, and here we have 30, a little above 30 degrees. So all in all, the batteries are cold. We consume 4 amp. It's not a lot, but we can see that the capacity is okay and the battery revived perfectly, so no issue. So the conclusion is that sometimes even that you see a very low voltage, you can try carefully to go up and see if you can do the charge. If you will see that the internal resistance in this case is 35 milliohm in the datasheet, so in 2 cells it's exactly the half, so it's about 17 milliohms, and this is what we've seen while charging it. So by the capacity and the internal resistance and the heat while charging and discharging, you can conclude if you successfully could revive the cells or not. So that summarizes all. Thank you all, and bye.